Welcome back. In the previous lessons, we covered all the major transmission media: twisted pair, coaxial cable, microwave, satellite, and fiber optics. Now comes a fundamental question. Once we have these physical links, how do we actually establish a communication channel between two endpoints? There are two fundamental networking modes: connection-oriented and connectionless. In connection-oriented communication, a dedicated path is established before any data flows. The path remains reserved for the entire session. Think of it like a phone call. You dial, the connection is set up, you talk, and then you hang up. In connectionless communication, there is no pre-established path. Each data unit, called a packet, is sent independently and may take a different route through the network. Think of it like sending letters through the postal system. Each letter finds its own way. These two modes lead us to the two major switching techniques: circuit switching and packet switching. Let us start with circuit switching. In circuit switching, a dedicated physical path is established between the sender and receiver before communication begins. This path, called a circuit, remains exclusively reserved for the entire duration of the call or session. The process has three phases. First, circuit establishment. The network finds and reserves a complete path from source to destination. Second, data transfer. Information flows continuously along the reserved path. Third, circuit disconnect. When the session ends, all resources along the path are released. The traditional telephone network, the PSTN, is the classic example. When you make a phone call, switches in the network create a dedicated 64 kilobits per second channel from your phone to the other phone. Circuit switching has important advantages. It provides guaranteed bandwidth with no congestion during the call. Latency is very low and constant, which is ideal for real-time voice. Quality of service is guaranteed because the path is dedicated. There is no overhead for addressing each piece of data. However, circuit switching also has significant drawbacks. The biggest problem is bandwidth waste. During silence periods in a voice call, the circuit remains reserved but carries no useful data. Studies show that in a typical phone call, each direction is silent about 50% of the time. Setup time is required before communication can begin, and the circuit is vulnerable. If any link in the path fails, the entire connection drops. Now let us explore packet switching. In packet switching, data is divided into small units called packets. Each packet contains a header with the destination address, sequence number, and other control information. Packets are sent independently through the network. Each node, called a router, examines the packet header and forwards it to the next node based on routing tables. This is called store and forward. The router receives the entire packet, stores it briefly, checks for errors, and then forwards it. Different packets from the same message may take different paths and arrive out of order. The destination reassembles them correctly using the sequence numbers. The key advantage of packet switching is statistical multiplexing. Multiple users share the same network links. When one user is not sending data, others can use that bandwidth. This makes packet switching far more efficient than circuit switching for bursty data traffic like web browsing, email, and file transfers. However, packet switching introduces its own challenges. Packets may experience variable delay called jitter because each packet may take a different route or wait in different queues. During congestion, routers may drop packets if their buffers overflow. Lost packets must be retransmitted, which TCP handles at the transport layer. There is also overhead. Each packet carries header information, which reduces the effective data throughput. Let us now compare circuit switching and packet switching side by side. In terms of path, circuit switching uses a dedicated fixed path. Packet switching uses dynamic, potentially different routes for each packet. Bandwidth usage. Circuit switching reserves bandwidth even during silence. Packet switching shares bandwidth dynamically through statistical multiplexing. Delay characteristics. Circuit switching provides constant, low delay. Packet switching has variable delay depending on network load. Reliability. In circuit switching, a single link failure breaks the whole call. In packet switching, packets can be rerouted around failures. Quality of service. Circuit switching guarantees QoS. Packet switching requires additional mechanisms like diff-serve or MPLS for QoS. Best use cases? Circuit switching is ideal for real-time voice where constant delay and guaranteed bandwidth matter. Packet switching is ideal for data applications where efficiency and flexibility are more important than constant delay. The modern internet uses packet switching, but modern voice calls over the internet, VoIP, use packet switching with special QoS mechanisms to achieve the low delay that voice requires. So the trend is clear. Packet switching has won, but circuit-like guarantees are layered on top when needed. Let us summarize today's lesson. Connection-oriented communication establishes a path before data flows. Connectionless communication sends each packet independently. Circuit switching creates a dedicated path for the entire session. Advantages: guaranteed bandwidth, low constant delay, no congestion. Disadvantages: bandwidth waste during silence, setup time, single point of failure. Packet switching divides data into packets that travel independently. Advantages: efficient bandwidth sharing through statistical multiplexing, resilience to link failures, flexibility. Disadvantages: variable delay and jitter, possible packet loss, header overhead. The PSTN uses circuit switching. The Internet uses packet switching. Modern networks combine both approaches to get the best of both worlds. In the next lesson, we will explore the PSTN infrastructure in detail. The hierarchy of switching offices, local loops, trunks, and signaling systems that make telephone calls possible.